Hi everyone, welcome to Nord Campus Calculus Problem Solutions. This is Chapter 1, Section 1 and Lecture 9, Trigonometric Functions, Angle Measure. In this lecture, we are moving on to angle measure in calculus. Understanding angle measures will help you throughout trigonometric functions. Do not forget to subscribe to the channel and leave a comment if you have any questions and suggestions. Angle. An angle is formed by two rays sharing a common endpoint called vertex. And directed angle that we use in trigonometry, directed angles. A directed angle has a specific rotation from the initial side to the terminal side, usually measured counterclockwise, as positive and negative angles are measured clockwise. Principal measure of an angle. The principal measure of an angle is the unique angle coterminal with it that lies between 0 and 360 degrees, or 0 and 2 pi radians. Degree. A degree is a unit for measuring angles. One full circle is 360 degrees. And radians. A radian is the angle formed when the arc length of equals the radius of the circle. This is the radius of the circle, and this is 3 centimeters, and this is the arc length, and it is also equal to r. And unit circle. The unit circle is a circle with radius 1 centered at the origin of the coordinate plane, and it's used to visualize angles and find the values of trigonometric functions. First example, draw an angle of 60 degrees and indicate its initial and terminal sides. The initial side will be along the positive x-axis. This is our initial side, and since the angle is positive here, the terminal side will be at the counterclockwise. Terminal side will be this. This is 60 degrees, and this is the way of the angle. And the next question. Draw an angle of minus 60 degrees and indicate its initial and terminal sides. Again, the initial side will be along the positive x-axis, but since this time the angle is negative, we will rotate it clockwise, and this is 60 degrees, and this is 60 degrees, and our angle is this. Find the principal measure of 450 degrees. The principal measure of an angle is the equivalent angle between 0 degrees and 360 degrees, or 0 radians and 2 pi radians. To find it, we subtract or add full rotation of 360 degrees until the angle falls within this range. So we subtract from 450 360. Here, since 460 degrees is greater than 360, we subtract 360 degrees and get 90 degrees. Therefore, the principal measure of 450 degrees is 90 degrees. And next example, find the principal measure of minus 360 degrees. The principal measure O and angle is the equivalent angle between 0 degrees and 360 degrees, or 0 to 2 pi radians. To find it, we subtract or add 360 degrees until the angle falls within this range, 0 degrees and 360 degrees. Here, minus 300 is less than 0, so we add 360. Minus 300 plus 360, and we get 60 degrees. Therefore, the principal measure O minus 300 is 60 degrees. Next example, find the principal measure of 1460 degrees. The principal measure of an angle is the equivalent angle between 0 and 300 degrees. To find it, we subtract or add full rotations of 360 degrees until the angle falls within this range. Here, 1460 degrees is greater than 360 degrees, so we subtract 360 degrees repeatedly until we get an angle between 0 degrees and 360 degrees. So you can also use this way. You can also divide by 360 degrees to instead of repeatedly subtracting it. 60 degrees divide by 360, 3 times 0, 0, this is 4 times. 4 times. And so, since the answer is 20, this means that our principal measure is 20 here. We can also do this like this. From 1460 degrees, we can repeatedly subtract 360 degrees 4 times, and we can also find 20 by this way. Find the principal measure of 7 pi over 3 radians. The principal measure of an angle, again, is the equivalent angle between 0 and 2 pi radians. To find it, this time we subtract or add full rotations of 2 pi radians until the angle falls within this range. 0 to 2 pi is our range. Here, 7 pi over 3 is greater than 2 pi, so we subtract 2 pi. 7 pi over 3 minus 2 pi, and this is equal to pi over 3. Therefore, the principal measure of 7 pi over 3 is pi over 3. And next example, find the principal measure of minus 5 pi over 4 radians. Again, the principal measure should be between 0 and 2 pi radians. To find it, we whether subtract or add full rotations of 2 pi until the angle falls within 0 and 2 pi range. Here, minus 5 pi over 2 is less than 0. So we add 2 pi, and minus 5 pi over 4 plus 2 pi is equal to minus 5 pi over 4 plus 8 pi over 4. And this is 3 pi over 4. So, therefore, the principal measure, or minus 5 pi over 4, is 3 pi over 4. And the next example, and this example is about unit circle. On the unit circle, if the x coordinate is 1 over 2, what are the possible y coordinates? What are the possible y coordinates? This is our unit circle. This is our unit circle. And if the x coordinate, our x coordinate is 1 over 2, what are the possible y coordinates? Actually, on the unit circle, every point x and y must satisfy the equation x squared plus y squared equals 1, because the radius of unit circle is 1. And if this is the point, we need, this is x, this is y, x squared plus y squared should be equal to 1. So if we are given the x coordinate, we can find the possible y coordinates by using this relationship. Or if we are given the y coordinate, we can also find the y coordinates using, again, this relationship. We are given the x coordinate and it's 1 over 2. To find the y coordinate, then this means y coordinate will be here and here. Let's say the x coordinate 1 over 2 and y coordinate, let's say k. Then if we use this equation, 1 over 2 square plus k square should be equal to 1. 1 over 4 plus k square should be equal to 1. Then k square is 1 minus 1 over 4, and this is 3 over 4. K square is 3 over 4. Then k should be equal to plus or minus square root of 3 over 2. This means k may be plus square root of 3 over 2, that square root of 2, or minus square root of 2. What are the possible y? Yes, there are two possible y values, and minus and plus square root of 3 over 2. Next example, on the unit circle, find all points where x equals to y. Again, on the unit circle, every point x and y must satisfy the equation x squared plus y squared equals to 1. So if we are given any x and y coordinates that are equal, we can take x equals k and y equals k. So k squared plus k squared equals to 1. This means 2 times k squared equals 1. K squared is equal to 1 over 2. Then k can be plus or minus 1 over square root of 2. So the points are minus 1 over square root of 2 minus 1 over square root of 2. This is the first point. And 1 over square root of 2, 1 over square root of 2. This is the second point. And the last questions. On the unit circle, if a point lies in quadrant 2 and has y equals 1 over 2, what is the x coordinate? Let's draw the unit circle again. This is our unit circle, and this is the first quadrant and this is the second quadrant. In question, we are given y equals 1 over 2. Y equals 1 over 2. This means, let's take here k, and we know that here k should be negative. So, and as you know, to determine the possible x values on the unit circle when the y value is known, we always use the same fundamental equation, x squared plus y squared equals 1. Here our equation 1 over 2 squared plus k squared is equal to 1. 1 over 4 plus k squared equals 1. Then k squared should be 1 minus 1 over 4, and this is equal to 3 over 4. Then k should be square root of 3 over 4 plus and minus. Then k equals plus and minus square root of 3 over 2. But here the axis value should be negative. So the answer will be minus square root of 3 over 2. See you on the next video.